You tap your phone. It reacts instantly. No lag, no hesitation. It feels so normal now that we kind of forget how weird it actually is. Because think about it. Your finger isn't a button. You're just touching a piece of glass. So, how does a flat sheet of glass know where you touched and respond fast enough to feel like actual magic? Welcome to the smart side. We're all about learning new stuff every day, and today we're diving into the hidden physics that makes your touch screen feel so, well, responsive. Here's my promise to you. By the end of this, you'll understand touch screens so well that you could explain them to a friend without sounding like a textbook. First, let's clear up a huge myth. Most people think touch screens feel pressure, like you press down, the phone feels the force, and that's it. But on modern phones, it's not really about pressure at all. It's about electricity. Specifically, it's about how you affect an electric field. Because you, yes, you, are slightly conductive. Not in a cool superhero way, more in a the human body is full of water and salts way. So, when your finger even gets close to the screen, it changes the screen's electric environment just a tiny bit. And that tiny change? That's exactly what the phone is looking for. Here's a simple way to picture it. Imagine an invisible trampoline stretched tight. If nothing's touching it, it stays perfectly flat. But as soon as you bring your hand near, it starts to dip. A touchscreen is basically that. Except the trampoline is an invisible electric field, and the dip is a measurable change in something called capacitance. Capacitance. Cap-a-tans. It sounds a bit technical, but don't worry. It basically just means how easily something can hold a tiny electric charge. Now, hidden under that glass is a transparent grid made from a super thin conductor. You can't see it, but I promise, it's there. Your phone is constantly sending tiny signals through that grid and asking itself, did anything change here? How about here? Most of the time, the answer is no, but then your finger comes near. And suddenly, one specific spot on that grid reacts. And here's the real reason it feels so fast. The phone isn't waiting for you to touch it, so it can start paying attention. It's already paying attention. All the time. It's scanning that grid over and over. Dozens, sometimes hundreds of times every single second. So when you tap, you're not starting the system. You're interrupting a system that's already running at full speed. Another common question is, does the screen actually see my finger? Like there's a tiny camera under there? Nope. It's not seeing. It's measuring. The grid has rows and columns. When your finger gets close, it disturbs the electrical pattern in a small area. The phone reads that pattern, finds the exact center of the disturbance, and turns it into coordinates. Basically, this touch happened right here. And when you move your finger, that disturbed spot moves too. That's how the phone tracks you so smoothly. That's a swipe. That's scrolling. That's you dragging an app across your home screen. Now, let's talk about multi-touch. Because this part is honestly pretty wild. How can it track two fingers at once? Or 5? Or 10? Well, it's not actually trying to detect a finger. It's just detecting changes on the grid. Two fingers just create two separate change spots. So the phone tracks both at the same time. No problem. That's why pinching to zoom feels so natural. The phone watches the distance between your fingers and updates it constantly, so the zoom feels smooth instead of jumpy. But if the screen is this sensitive, why doesn't it just go crazy? Why doesn't it think you touched it because of a nearby charger or random electrical noise or even just the air? Because responsiveness isn't just physics, it's physics plus filtering. Inside your phone is a touch controller, a small chip whose entire job is deciding what actually counts as a real touch. It looks for the specific shape of a fingertip. It checks the timing. It checks for stability. It basically ignores the tiny glitches. See, a real touch usually appears quickly, stays steady for a moment, and then disappears. Static or noise doesn't behave that cleanly. And when you swipe, a real finger makes a smooth, logical path. Noise is messy. So the controller just filters that mess right out. That's why a great touchscreen feels incredibly sensitive, and also totally calm. Now, the glass itself matters too. It's not just there for protection, it's part of the whole system. Your finger doesn't actually need to touch the sensors directly. The electric field passes right through the glass. That's how it senses you. But things like thickness or special coatings can change that sensitivity. And yeah, that's why some screen protectors can make your phone feel a bit off. And water? Water can really confuse things because it conducts electricity in its own way. It smears the signal and makes the phone ask, wait, is this a finger or just a raindrop? Same goes for gloves. Most gloves don't work because they insulate you. They block your finger's conductivity from reaching the screen. Touchscreen gloves fix this by adding conductive thread, allowing your body's effect to reach the glass. Now, here's the big reason some phones feel faster than others: latency. Even if the screen senses your finger instantly, the phone still has to process that data, decide what it means, and then update what you see on the display. Engineers fight lag in a few different places: how often the screen scans for touch, how fast it filters out noise, and how quickly the display refreshes. That's why two phones can look identical on a spec sheet, but feel totally different when they're in your hand. And believe it or not, prediction is part of that smooth feeling. When you swipe, the system doesn't just follow your finger. It actually guesses where you're about to go based on your speed and direction. It's trying to stay one step ahead, so the motion feels natural. If it waited for 100% certainty every millisecond, everything would feel just a tiny bit late. So, the magic is really just a stack of smart ideas. Invisible electric fields, tiny capacitance changes, a sensor grid, fast scanning, noise filtering, and a little bit of future prediction. And here's the big aha moment. Your touchscreen feels responsive, not because it reacts fast after you touch it, but because it was already measuring you before you even made contact. So next time you tap your screen, just remember what's actually happening. You're not pressing a button, you're slightly warping an electric field through glass. And your phone is turning that warp into a decision, hundreds of times every second. One last thought. If a screen can track your finger this precisely, what else could these surfaces detect in the future? Maybe your heart rate? Your identity? If you enjoyed this and learned something new, please hit that like button and subscribe to The Smart Side. It genuinely helps us keep making these videos for you every day.